Hello, everyone, and welcome to the Restricted Crossing U-Turn R-CUT Intersections webinar. My name is Paula Hyman. I'm filling in for Victoria Beal from the Ohio LTAP Center. We have quite a few people still joining, so I'm talking kind of slow just to stall just a little bit. Before we begin, I do want to cover a couple of housekeeping items. If you have questions throughout this presentation, I'm going to ask that you please type them into the questions box. Go ahead and locate that now. The presenter is going to address your questions periodically throughout the presentation. Go ahead and locate that questions pod for me. Type a quick hello or hi, just to make sure that you know where it's at and where it's located. Lastly, today's presentation is available for download in the handout section. If for some reason you're unable to download the handouts and you would like a copy of it, we can make sure that that will be emailed to you following the session. So those are the items that I needed to cover. I want to thank you in advance for your participation with that. I'm going to pass things off to Mr. Mark Doctor. Mark, you ready?
Yeah, thank you, Paula. Thank you very much. I also want to welcome everybody, and it's great to see the high number of people that we have on today's webinar and this great interest in restricted crossing U-turn intersections. Again, my name is Mark Doctor. I'm with the Federal Highway Administration's Resource Center, the Safety and Design Technical Service team. And I've been very privileged to be involved with innovative intersections for a number of years, including the restricted crossing U-turn, and conducted a lot of training, and very happy to bring this webinar session to you today. So what I'd like to cover today is starting off with the basics of what is a restricted crossing U-turn intersection, how do they work, and where are they applicable? Where or why are they advantageous? What are the benefits? Are they beneficial to pedestrians and bicyclists? Short answer, yes, they can be. And very excited to show you how that can be done. We'll talk a little bit about some of the fundamental design considerations that you should be aware of. And are there any special signs or pavement marking needed? Well, not really, but I'll show you some examples of what can be done with the signing. So this is what we're going to cover today. And the restricted crossing U-turn intersection. Well, this is not one. This is a basic open median intersection. And this is really why the R-CUT got its start. I'm sure you're familiar with these intersections. They're all over the place. You may even have some in your jurisdictions. I know they are common throughout Ohio. So of a 4-lane divided roadway, the minor street intersection in a rural setting where we have high speeds. And the problem with these open median intersections is it's basically a free-for-all and just a lot of space to work with. And notice it's a typical median, not really wide enough to be treated as an area where you would have two separate intersections. You might be able to store a small passenger car in there, but certainly not a truck. And even if you can hang out in the middle there, there's conflicts with vehicles that are turning left from the major to the minor and traffic coming out from the minor. So it was these types of intersections that really led to the restricted crossing U-turn intersection. And if you see the video up on the top of the screen, this is a video from Minnesota. Oh, yeah. So that's exactly the type of problem that is very common at these types of intersections. As drivers, we do an okay job of judging for speeds and gaps on the near side of a divided roadway, but it's the far side that we have trouble with in terms of making those judgment calls. So inevitably at these types of open median intersections, we oftentimes see these far side angle collisions. They tend to be high speed, a 90-degree angle of impact, or a T-bone style, which is really the worst. It's actually even worse than head on in many ways in terms of how our vehicles are designed to absorb the energy. So if you see these far side right angle collisions on a typical rural divided highway, open median type intersection, you're not alone. It's a very common safety problem. And that's really where the R-CUT, the restricted crossing U-turn intersection, has its niche, or at least has its initial core niche. And it's a at-grade intersection, so it's not a interchange, it's not a grade separation, it's an at-grade intersection. And from the perspective of traffic on the major highway, you can make all movements. You can make a right turn onto the minor street, you can make a left turn from the major to the minor, and of course you can keep going through. The difference is coming out from the minor street. All traffic coming out from the minor road makes a right turn, and if they didn't want to make a right turn, if they wanted to make the crossing maneuver or a left turn, they go downstream, utilize a U-turn bay, and then come back. So really the distinguishing feature is really only noticed from the minor street traffic. And if it's a rural type setting, perhaps that minor street traffic volume is relatively modest. So all traffic coming out of the minor street would make a right turn. If they wanted to make the left turn movement or the crossing movement, they would utilize the U-turn bay to come back. Now these intersections can be signalized. Those movements can be signalized. They don't have to be stop control. So the restricted crossing U-turn, it is also known by other names. What's in a name? Well, would an intersection by any other name be as sweet? Well, yes, it would. So the R-CUT is also known as J-turns or J-turn intersections, reduced conflict intersections, super streets, synchronized streets. The North Carolina Department of Transportation utilizes that term. What I would propose is that we do away with the names completely and just refer to them by their symbol, and we can call them the intersection formerly known as an R-CUT. Now, one of the problems with a webinar is I don't get to see the faces of people, and I can't tell whether you like my bad jokes or don't like my bad jokes. But a benefit is you can't throw fruit at me. So that's another good thing about a web-based format. But just wanted to point out that there are different types of names that the R-CUT goes by, and I really don't care what we call them. The important thing is the concept. That's the key benefit. And when we talk about innovative intersections, I always like to point out that what are the differences from the perception of the traveling public? So at an R-CUT, things are the same as a traditional intersection if you're a driver on the major street. So you can make all movements. You go through, you can make a right, you can make a left, just like you would at any other intersection. And for a pedestrian, if you're on the major street crossing the minor street, that's basically the same also. The only differences are for traffic coming out of the minor street, and if they didn't want to make the right turn, the through movement and the left turn is made by way of the U-turn. And also for pedestrians and cyclists that are coming from the minor street wanting to cross over the major road, that's going to be different as well. And I'll show you how that crossing maneuver is made for pedestrians and cyclists coming up. So the R-CUT, it can be signalized or unsignalized. It can be in a rural setting. It could be in a suburban setting. Probably not going to be in an urban core simply because we typically don't have this kind of divided highways. Not to say that you couldn't. In fact, there are some downtown areas that do have those boulevard median type of facilities. So it's possible, but predominantly you're going to see these in the rural and suburban context. It's primarily going to be on a high-speed roadway, although you could apply it on a lower speed roadway. The intersection is applicable for a 4-leg intersection, also a 3-leg or offset T's. I'll show you some examples of that. It's typically applied on multi-lane highways, multi-lane divided highways, but it could be applied on a 2-lane roadway. And I'll show you a sketch of how that could be done. And we'll talk about the multimodal advantages, or some of the concerns, but also advantages for the vulnerable users with the R-CUT. So there are variations, the closed median style, a 3-leg or offset T, or applying on 2-lane highways. So here's an example of a closed median variation. So in this variation, the left turns from the major street to the minor street are made by way of going past the main intersection and then utilizing the U-turn bay to come back and then basically make a right turn. So it is possible to have a closed median, a variety, a couple advantages of where this could be applied. Let's say the alignment of the two directions on the divided highway are different. Maybe it was constructed at a different time. Maybe it was an original 2-lane roadway where the other 2 lanes were put in at a future date and maybe with a different alignment, or a profile. So that could be a possibility, or just where the topography may make it challenging, maybe in a mountainous area. So closing off the median can have advantages. And in this particular one, you see the pedestrian crossing path go through. It actually makes it easier for pedestrians. And here's an example of an Ohio example of an R-CUT under construction in Stark County. And it is a closed median variety. And from the proposed sketch sheet, it shows a bicycle crossing going across. We're very interesting. I'll show you an example, another example of the bicycle crossing, but that is a possibility when we close the median to actually have an improvement for pedestrians and cyclists. So the closed median variety certainly is possible. 3-leg R-CUTs. A R-CUT can be applied on a 3-legged intersection where there's no minor street on the other side. The left turn maneuver is made by way of making a right turn and then utilizing the U-turn bay to come back. And the option for using 3-legged intersections is offset Ts. They don't have to line up. The minor street approaches don't have to line up. In fact, there's an advantage when we talk about pedestrian treatments. There's actually an advantage to having the offset T alignment. And I know a lot of projects that we've done in the past have tried to line up these offset approaches at intersections. We reconstruct the alignment to bring the two together. Well, if you've got an existing scenario where you've got two offset intersections like this, the restricted crossing U-turn option may be very good as opposed to reconstructing the alignment on one of the approaches, trying to bring them together into one intersection. There are actually advantages to the offset variety. So here's a sketch of what I was talking about with regard to applying this on a 2-lane roadway. Theoretically, it doesn't have to be a major street that is a 4-lane divided street. So the concept could be applied on a 2-lane roadway or a 3-lane roadway with alternating passing sections. But the main idea being that we close off the median in between the minor streets and have traffic coming out from the minor street make a right turn and then a U-turn, and then the same thing with the left turns from the major to the minor, have those be made by way of the U-turn and then coming back. So it is possible to apply it on a 2-lane roadway as well. Several agencies are looking into that concept. The traffic control can be stop control or yield control, or it can be signalized. And if it's signalized, the signals provide the stoppages in major street traffic. The signals provide for the gaps to come out from the minor street, and the signals can also control the creation of gaps for the U-turn maneuvers. And I'll talk about how the signals work, even though it looks like there are 4 signals, the main intersection and then the 2 U-turn bays. It's actually functioning like one signalized intersection, and they actually all work within 2 signal phases, which is very, very powerful. and hence the name super streets that are sometimes applied with these types of intersections. We'll talk about that as well. So here's an example, an Ohio example. So if we go to Fairfield, State Route 4 bypass at Sims Road, a signalized example of the R-CUT or super street. And if you look at the minor street, that is a triple right turn lane that is coming out from the minor street, and a double U-turn bay coming back. And it does kind of show that even with the minor streets, it is possible to accommodate a fairly significant amount of volume, triple right turns coming out of there, double U-turns. So the signalized R-CUT, a very powerful intersection, even in a suburban higher volume type of context. Here's an example of the U-turn bay that is signalized, dual U-turn lanes. And another signalized example, a good case study out of Minnesota. Minnesota Highway 65 at Viking Boulevard. And previously, this was a signalized intersection that was then converted into a signalized R-CUT. The problem when it was a normal signalized intersection with just a wider median, open median like that, that wide median added 7.5 seconds of time to clear the intersection. And because of how the intersections aligned, each approach on the minor street had its own phase. So that was 15 seconds of delay time per cycle. And with the fairly significant volumes, especially in the morning peak period, that resulted in some significant delays. And sometimes drivers would have to wait through 2 or even 3 cycles of the signal, a long 3.5 minute cycle length. Well, since the R-CUT was put in, that no longer happens. It is a far more efficient traffic signal scheme. So the R-CUT, the signalized version, as volumes get higher, and when we talk about feasibility, it really comes down to not so much traffic volumes on the major street, but the traffic volumes on the minor street. And as traffic volumes on the minor street get higher and higher, well, the advantages or the feasibility of the R-CUT starts to diminish. And if we have higher minor street through volumes, in particular, other forms of innovative intersections may start to take over as a better choice. So let me pull up a poll question here. If we think about combinations of traffic for what would be most favorable, I've given you 3 choices. So high volumes on the major street and high volumes on the minor street, high volumes on the major and low volumes on the minor, low volume major and a high volume minor. I left out the easy one of low volume on both, because with low volumes, you can do almost anything. So I'm going to ask, go ahead and open the poll.
All right, I have the poll open, and while they are voting, let's go ahead and get to a couple of questions we had come into the questions box. Does that sound okay?
Yeah, Paula, that'd be great.
Okay, so first question came in, says, and this is from Richard, how do the R-CUTs compare to a Michigan U-turn?
Great question, Richard. Yes, there's a lot of similarities. So the Michigan U-turn, which also has other names, a median U-turn or a through turn type intersection, but it's a similar concept. And typically the Michigan U-turn or Michigan left turn or median U-turn allows the minor road through movement. So that's one key difference. It's about which movements get redirected. So with the restricted crossing U-turn, typically it's the minor street through and the minor street left that get redirected. With the Michigan U-turn or median U-turn, it's left turns from both the major and minor street that are typically pushed down to the U-turn bay to come back. So the median U-turn or Michigan U-turn is a similar form of intersection, but a little different in terms of what directions get relocated. So they are cousins. They're very much related, but just slightly different in terms of which movements get redirected to the U-turn bay. Great question.
Okay, Terrence, Valerie, and Bruce all enjoyed your joke.
That's good, because I'll keep them coming then. You encourage me with my bad jokes. That's fine.
All right, Richard asks, what criteria is used to make a decision to put traffic signals at the U-turns?
Excellent question. So I'm going to, coming up real soon, I'll talk about volume thresholds, but short answer is it's really about the volumes.
Okay, next question is, one moment. How is the distance from the right turn to the U-turn determined?
Excellent question, and I am going to cover that coming up when we talk about some of the design issues. Great question. Hold that
Okay.
thought.
Next question. Seems like it might be difficult for trucks to make the U-turn in a timely manner without a signal. Are there truck volumes that might be problematic?
Great question. So yes, truck volumes are certainly a major consideration. The U-turn maneuver can be designed geometrically through the provision of a bulb out or a loon, which I am going to show coming up when we talk about design. And yes, when we think about the need for signalization, it's not just total volumes, but truck volumes that we need to consider, because a truck does need a longer gap to make the U-turn maneuver. So if we have lighter truck volumes making the U-turns versus heavier truck volumes, that can certainly make a difference in terms of where we might decide the tipping point is from going to non-signalized to unsignalized. So yes, great question.
Okay. For the super streets with 4 signals, do they operate off one controller?
They can, yes. It's probably easier to do so. There are some agencies that choose to go with multiple controllers, but they can be run off of one.
Okay, for the signal lane R-CUT, does the U-turn need to be stop controlled?
Does the U-turn need to be stop controlled? Theoretically, it could be yield controlled.
Okay. Okay, and what is the average reduction in the number of signal phases with an R-CUT?
Great. So I'm going to talk about how the R-CUT typically gets us down to a 2-phase signal, which is far superior to the multi-phase if we're providing protected left turns.
Okay, that is all the questions that I have in the questions box at this time. I am closing the poll. And we are going to share the results. We have 80% that voted for high volume major street and low volume minor street. We have 14% vote for high volume major street and high volume minor street, and 6% voted for low volume major street and high volume minor street.
All right, very good. Thanks, Paula. So yeah, usually what's most favorable is going to be where we have lower volume on the minor street. Now, if we do have higher volume on the minor street, it also depends upon where the movements are going to and whether they're making the right turns, the left turns, or the U-turns. But that was great that everyone's got that concept. So the real limitation from a volume standpoint is controlled by the minor street demand. The major street demand really depends upon whether we got a 4-lane roadway, a 6-lane roadway. You can even have an 8-lane or theoretically even more for the major street. There's really no limit for major street roadway volumes. The limitation comes from the minor street. And the diagram you're seeing here comes from the Federal Highway Administration's informational guide on R-CUTs. And there's nothing magical about these volume thresholds, but these are guidelines. So up to about 5,000 cars a day, so an average daily traffic of about 5,000, a minor street can operate unsignalized. And again, there's always reasons why we may want to deviate from that. And it doesn't say that at 5,001 cars, I've got to stick in a signal. No, it's just that as a rule of thumb, if you're less than 5,000 cars a day on the minor street, chances are unsignalized operations are going to work just fine. And then for signalizing the R-CUT, that can typically accommodate minor street volumes up to about 25,000 vehicles per day, which is not so minor. That's a fairly significant minor street volume. And even this threshold is by no means an absolute. So obviously our risk for delay gets a little higher with higher volumes, but these are some general guidelines to think about the applicability of the R-CUT. So it does depend very much upon the actual turning movements. So here's another poll question or another choice that we have. So this is minor street approach volumes, say peak hour minor street turning volumes. And we got the left turns, the through movement from the minor to the other side minor, and the right turn. So between these three choices, A, B, and C, based upon those turning counts, what do you think would be most favorable for an R-CUT? So Paul, if you can go ahead and open the poll here.
All right, it is open. And we do have a question in the questions box. Do R-CUTs accommodate large farm vehicles safely and effectively?
Great question, and a very significant issue. So what agencies have tried to do to accommodate slow moving or oversized farm equipment is to basically extend the U-turn lane, the bay or the U-turn lane, all the way back to the main intersection. So for example, and again, if we're dealing with a slow moving piece of farm equipment, unlike a vehicle or a car that can quickly accelerate, this slow moving piece of equipment, you really don't even want it on the roadway. So by pulling the U-turn bay all the way back, when there's a sufficient gap for the farm equipment to clear the two lanes of traffic, they basically are able to get into the turn bay or the lane that leads up to the turn bay. And so they can continue slowly to the U-turn bay, get to the U-turn bay, wait for another gap. And that's another great thing about the R-CUT. Traffic only has to wait for a sufficient gap in one direction at a time, which can be very advantageous rather than wait for both directions to clear out, especially for a slower moving vehicle like a farm vehicle or oversized truck. With the R-CUT or J-turn, you only have to worry about one direction at a time. So to design for that slower moving piece of equipment, allow them to ride the U-turn lane, make the U-turn, and then what agencies sometimes do is reinforce the shoulder or lengthen the shoulder on the other side so that, again, the farm equipment doesn't have to take a lane. They can basically ride down the widened shoulder or the enhanced shoulder to get to the minor street. So that is one strategy that some agencies have utilized to try to design for the larger or slower farm equipment. Great question.
Okay. Also, if anyone is having trouble having the ability to vote on screen, if you exit full screen mode, you will have the ability to select your decision on the screen there. So for those who are having trouble answering the poll question, we have about 78% of the votes in, and I'll go ahead and close this here shortly. Give you a couple seconds. That was all the questions also. Oh, we have one more.
Great.
We know that there are significant safety benefits of R-CUTs. Are there any crash reduction factors for R-CUTs?
Yes, great question. So we are to a point now where we are able to develop crash reduction factors. On the crash modification factor clearinghouse, you'll find some examples of studies in North Carolina where they have a lot of R-CUTs. They have generated a safety evaluation report I'll share with you some of that information coming up. So yes, we're seeing very significant crash reductions. There's, I wouldn't say a universally agreed upon crash modification factor at this point. There of course is variation in any treatment that we put in, but the crash reductions certainly on an order of magnitude of 60 to over 80%. Very, very impressive, especially with the more severe crashes.
Okay, so we have the results of the poll up right now, and about 6% chose option 1, left 100, 35% chose option 2, left 150 through 300, and then 59% chose option 3.
All right, good. So still the majority there. And just to summarize it, so typically, if we have higher right turn volumes, if the natural demand is for traffic on the minor street to want to turn right anyway, that's going to work in our favor because those are volumes that are not going to have to make the U-turn. So if there's little demand for people to go from one side of the minor street to the other, let's say most of the traffic coming from the minor street is wanting to go a certain direction, hopefully the direction that the right turn takes them in, that is going to be advantageous. So the less traffic that has to make the U-turn, the better, typically. So good, glad most folks picked up on that. So thanks, Paula. We'll keep on going then, and get into our next topic. So we talked about what it is and where they're applicable. So now I want to talk about why are R-CUTs advantageous, and we've hit upon some of this already. Certainly, safety, crash reductions is a huge advantage, and the other one is when we signalize the R-CUTs and the efficient two-phase signal. So let me get into some of the details. Now, the safety one, I hope it's very intuitive as to why the R-CUT is so much safer. It takes out those far side right angle collisions. Those are the most severe type of collisions. And if we think of intersection crash risk in terms of conflict points basically represent the potential for a crash when a driver either fails to adhere to a traffic control device, whether they blow through a stop sign or run a red light, or if they make a judgment error. Let's say they misjudge a gap, a permissive left turn gap, or a crossing gap. Well, the conflict points basically represent the potential for a collision if a driver makes a mistake, a poor judgment, or violates a traffic control device. And with the restricted crossing U-turn intersection, we have basically taken away the potential for drivers to make those errors. And that's reflected in the fewer number of conflict points, and in particular, the reduction in crossing conflicts. It eliminates the possibility for that far side angle collision. So here's some of the safety data that has been collected by states that have implemented a lot of R-CUTs. North Carolina, possibly the most proficient in R-CUTs. This was a study that looked at 93 unsignalized R-CUTs across the state, 59% decrease in total crashes, and 88% reduction in fatal and severe injury crashes. That is amazing. That's on par with the type of crash reductions we see from roundabouts in terms of reductions in fatal and severe injury crashes. Very, very impressive. Maryland also has a lot of unsignalized R-CUTs, and that they've done their own studies and crash reductions between 28 and 44% on some of the Maryland R-CUTs. Missouri has done an evaluation of R-CUTs, J-turns, and found very impressive crash reductions. And one of the things I like about Missouri's study is they included a public opinion survey. And one of the things that the public reacts to or can be a hot point to the public is the concern that coming out from the minor street, they can no longer make the left or the direct crossing. And they have to go all the way down, miles and miles down the road. No, it's not miles. I'm going to get to that. But it may seem like miles to the traveling public, and make the U-turn and come back. So in their mind, they're envisioning it to be a major disservice. Well, it's not. And what I liked about the public opinion survey from Missouri is they asked people, the locals coming out from the minor street, was there an adverse effect to their travel time? And no, the vast majority, definitely not. In fact, the R-CUT or J-turn can even decrease travel times, because if you think about it, when you're coming out from the minor street, if there's some significant volumes, again, non-signalized, you may not be the first one at the stop bar or at the stop sign at an open median intersection, and you've got to wait for a gap in both directions of traffic. And that may take a while for a gap in both directions. It could actually be quicker if everyone coming out of the minor street only needed a gap in one direction, made the right turn, made a U-turn, and come back. In fact, if you think about it, how often have you as a driver trying to make a left turn on an undivided street, I'd say an undivided 4-lane roadway, where you're waiting for a gap in both directions, and maybe you're pulling out of a driveway or a minor street, and it just seems like there's never a gap in both directions. So you make a right turn, and then an immediate left turn into another driveway, and then you make a right turn out of that driveway. And a lot of us make these J-turn type of movements informally when we don't have gaps. And so the R-CUT is really just a formal way of sometimes doing an informal maneuver that many of us make. So let's talk about the signalization of an R-CUT. So a little bit of traffic signal phasing 101. Hopefully this is a quick review for everybody. At a basic intersection, so a non-R-CUT, just a basic signalized intersection, if we have the traffic signal providing the green movement for the north-south movement, then we stop north-south traffic, we let east-west traffic go. So that is a basic two-phase signal, the simplest type of signal operation we can have. But typically we introduce protected left turn phases, the green arrow, especially as our left turn demands get higher and higher. And sometimes the minor street is not so minor, and so we provide a protected left turn phase on both the major and minor approaches. So we are introducing more phases, the protected left turn phase. And even though technically it's more like an interval, I'm going to refer to them as a phase. And so with dual protected left turn lanes, major and minor, so protected lefts for the major street. And then every time we introduce that protected left turn phase, we also have to introduce a yellow clearance interval, maybe a all red, a second or more of all red. Then the major street through movement, we give them green time, yellow clearance interval or change interval, all red clearance interval, protected lefts on the minor, because maybe the minor is not so minor. And again, the yellow clearance, all red, and then minor street through movement. And by the time you start to add all that up, every time we introduce a phase, a protected left turn phase, it's basically more lost time, more startup time, more lost time, and less time that can be given to the major street through movement. If you think about everyone getting a slice of pie, well, the major street movement gets a smaller slice of pie the more phases that we introduce, and typically more overall intersection delay. So anytime we can go from a 4-phase signal down to fewer phases, 2 phases being the best, we're basically giving an opportunity for more green time to the major street through movement. And that's the congestion fighting power of the 2-phase signal, or the super streets. So a signalized R-CUT does operate as a 2-phase signal. And the major street movement, when the major street movement gets stopped, when they get the red, that is when the minor street traffic gets the green to make the right turn coming out of the minor street. That's also the simultaneous time when the left turns from the major to the minor street are being made. So it is a protected left from the major to the minor, but that protected left movement occurs at the same time as the right turns coming out from the minor street, and the same time that the U-turn movement is being made. So when we stop the major street through, all other movements are being made. The U-turn maneuver, the left turns from the major to the minor, and the right turns coming out from the minor. So everything operates within a two-phase signal. Two-phase signals can possibly allow us to go down to a shorter overall cycle length. That might greatly reduce overall delay. Shorter cycle lengths can also reduce delay for pedestrians. It gives more opportunities for crossing, for getting the walk indication. So a lot of benefits of going with shorter cycle lengths, and certainly benefits with going with more green time for the major street through movement. Now, here's another significant advantage of signalizing R-CUTs. Each direction on the major street in an R-CUT is basically going to be operating like a one-way street. They're like one-way pairs, because you never need to stop both directions on the major highway at the same time. Because traffic is not coming out from the minor street making a left or a crossing, they're only making the right turn, we don't need to stop both directions at the same time. They're basically operating like one-way streets. That opens up a lot of possibilities. You can even have different cycle lengths in the two directions on the major street. So let's say we've got a heavy morning inbound commute pattern and a heavy afternoon outbound commute pattern. Theoretically, you can have different cycle lengths in those two directions, and also change them by time of day. So it's very powerful what can be done in terms of achieving good, efficient signal operations. With a two-phase signal, it's a lot easier to get signal progression. Signal progression is much simpler with fewer phases. So the two-phase signal really is quite advantageous. And let me give you another example. So a long time ago in a galaxy far, far away, we're in the little town of Walkerville, where we have a four-lane divided highway that comes into town. But as traffic volumes on that four-lane highway through town get heavier and heavier, the citizens of Walkerville want a bypass. So a bypass route is put in around the town, not full access control, but partial access control, but it does have at-grade intersections at some of the existing roadways on the bypass, and the bypass a four-lane divided highway. And anytime we build a bypass and open up that undeveloped land, well, the land is still cheap, but let's put the new high school out there. All right, so we develop a new high school. And yeah, with the traffic going to the new high school, yeah, let's signalize that intersection. And as more people are using the bypass, well, somebody wants to put in a big box store. And another big box store pops in. And this development, it doesn't happen overnight, but slowly over time, we get one permit for a driveway or an access connection, and then another permit for a driveway or access connection. And as those volumes build, yeah, let's give them a signal. All right, no big deal, only a couple of signals, right? And then we get some residential development occurring along the bypass. They get a signal. More residential development, new elementary school comes out, another signal, another big box store, more development, another signal. Before you know it, the bypass is now more congested than the route that goes through town. Well, why? Well, it happens slowly, but it's the traffic signals. There was none to begin with, but over time, as development picked up, we added signals. All right, so the citizens are now complaining. We've got congestion on the bypass. go ahead and fix the congestion problem on the bypass. So what did our heroic transportation engineers do? Well, we had more lanes. We widen the road, right? That's what we do. We build more lanes. So let's make it an 8-lane highway. Let's put in dual left turn lanes, even triple left turn lanes sometimes. Well, is that really solving our congestion problem? I love this picture because if you look at this picture, I can't even count how many signals are in this picture. It's at least 8 signalized intersections in the view here. Is it really the problem that we don't have enough lanes? Is that really the problem? No, it's got nothing to do with how many lanes, and adding more lanes isn't going to fix it. This 8-lane arterial here, would we solve the problem if we made it a 10-lane arterial? Certainly not. So one of the mantras that I want you to keep in mind is, it's the signals, stupid, or it's the stupid signals. And that's really the really contributor to perceived congestion problems, especially when we're operating those signals as our basic multi-phase signals, protected lefts from the major and the minor, and not a lot of green time, not a lot of opportunities for signal progression. And that's what contributes to the perceived congestion problem. There's a great case study, a great video case study that demonstrates this point. It's from North Carolina, in the Brunswick area and the Wilmington area. And I'm not going to play the video here, but you've got the slides to download, and I've given you this link onto YouTube to watch the video. I really encourage you to take the time to watch that North Carolina case study. It's this classic example of new development coming in, new box stores, new residential, and rather than put in traditional multi-phase signals, the development was handled with R-CUT signalized intersections, 2-phase signals. And notice they did not have to widen the 4-lane divided highway. It's still 2 lanes in each direction. It was a 2-lane or 2 lanes in each direction, 4-lane divided highway. It remains a 4-lane divided highway. It's not really the number of lanes that gives us the fighting power of congestion. It's how the signals are working. And we can typically accommodate the high demand, the increase in volumes, without necessarily having to add more lanes if we manage the signals properly. So in this North Carolina example, the traffic volumes increased from 28,000 cars a day to 42,000. And no widening, and most importantly, no noticeable increase in congestion with all that new development. So why are they advantageous? Yes, safety, but really and powerfully is with the signalized R-CUTs for developing areas. So next, I want to get into talking about pedestrian and bicycle advantages. Our first R-CUTs or J-turns really were predominantly in that rural context where there really weren't a lot of pedestrian or bicyclist activities, but we are evolving in terms of the designs that place a better emphasis on serving all roadway users. And when we think about what is good for pedestrians in terms of intersection designs, we want to minimize the conflicts with turning vehicles. We would like slower vehicle turning speeds, shorter crossing distances, and less delay for the walk indications. All 4 of these can be achieved with a R-CUT, the signalized R-CUT. So here is how the pedestrian would cross the major street at a signalized R-CUT. It is a Z type of crossing pattern. It's a little different than a traditional intersection, but that is typically the crossing pattern. It's this Z style. And so in the middle, that median channelization does serve as the pedestrian cut-through path. So here's an example. But the pedestrians are crossing one direction of traffic at a time. It is treated as a multi-stage crossing. Theoretically, a pedestrian that runs across could possibly make it in a single stage, but we don't really say that we don't talk about it as a single stage crossing. We assume that the pedestrian is going to take the crossing in 2 stages, so they will be in the center there for the next cycle to cross the other direction. However, when the pedestrian is in the center there, that is the same time as when the left turning vehicles are stopped. So you may think, well, I'm putting pedestrians in the middle of a busy highway. Well, yes, but it's one of those things that until you experience it as a pedestrian, it's one of those things you got to experience it to believe it. And when you're there in the center, it doesn't nearly have the feeling of awkwardness that at least personally I was expecting it to have. And I think a large part of that is the buffer or being there basically when the left turning vehicles are stopped, and kind of having the sandwich of stopped cars in between you as a pedestrian. So that is the Z crossing, and there are fewer conflict points, fewer conflicts between vehicles and pedestrians compared to a traditional intersection. We don't have the conflict with permissive left turns. We don't have the right turn on red. There are advantages, but of course disadvantages. The disadvantage being perhaps the difference of that Z-style crossing. You know, the first time a pedestrian does that Z-style crossing, it obviously is a different pattern, a different crossing pattern. But there are safety advantages from the perspective of fewer conflict points. And to answer the question, does it take longer for the pedestrian to cross the road? The answer is it depends on where you're coming from and where you're going to. So for example, if I'm just crossing the minor street approaches, if I'm going from A to B or C to D, that's likely going to be shorter because it's fewer number of lanes to cross, and more likely less delay for the signalization. I probably have, with a 2-phase signal, more walk opportunities in a given time period. So from A to B or C to D, there's probably an advantage to the pedestrian from the signalization standpoint. Now, from A to D, going from quadrant A to quadrant D, that's going to be longer because there's extra crossings involved. So to get from A to D, not only do you have to cross the major street, which would be a 2-stage crossing, but you also have to cross both of the minor approaches. So A to D is most definitely, or very likely, going to be longer. Going from B to C, that could be shorter, could be. It's even with a 2-phase crossing, because it's still 2 phases, but going from B to C under a traditional intersection would be 2 phases anyway. So it depends on where the pedestrian is going, where they're starting and where they're going. Now, here is a very exciting opportunity to enhance pedestrian service at signalized R-CUTs. If we have the U-turn bays, if we have a corridor of these, and if the U-turn bays are close enough that we can actually put a mid-block pedestrian crossing that takes advantage of those 2 signals that are there for the U-turn bays, we can actually have mid-block pedestrian crossings that don't interfere at all with the signalization scheme. They don't interfere with the signal progression, and they would not even increase the number of signals. Now, if we don't have a corridor of these, and if we're just having, say, a isolated, or if there's a great distance between the R-CUT intersections, you can still have a mid-block crossing, but for the one direction that wouldn't otherwise be stopped, we could either add a regular traffic signal to stop that movement, or do something like a pedestrian hybrid beacon to stop that traffic. But the R-CUT does open up this opportunity for more mid-block pedestrian crossings. Or if we have this scenario of the offset alignment, the offset T's, we can have a more traditional type of pedestrian crossing. Or the three-legged R-CUTs. The three-legged R-CUTs can also open up opportunities for more traditional pedestrian crossings without the need for the Z-style. For cyclists, for bicyclists, well, the only difference is going to be for cyclists coming out from the minor street. For cyclists on the major street, there's no difference. They can continue straight, they can make the left, they can make the right. The difference is for cyclists on the minor street that want to make the crossing maneuver, go over to the other side on the minor street, or make the left turn coming up from the minor street. So a couple options. The cyclist can dismount and walk across like a pedestrian. They can go like a vehicle, make the right turn, make the U-turn and come back. But I think we can see that whereas for a vehicle to make that maneuver, a cyclist, it's a little more demanding. So another opportunity is to provide the cyclist with a movement that vehicles can't make. And that's shown in the red line there, kind of a straight across cut through. So agencies have looked at things like either pulling back in the U-turn bay for a cyclist, having the cyclist the opportunity to make the U-turn nearer in than what vehicles would do. Or, and this is that Stark County example with the cut through. So if the median is closed, it could allow something like a bicycle crossing. Or even with an open median, it might be possible to do something like this, have a cut through to allow the cyclist to be able to go through and when there's a gap, get to the other side and continue down the minor street. So those are possibilities. Now that cut through the channelization, it's pretty rare, but sometimes for emergency vehicle access. Here's a case study where there's a fire hall on one side of the main highway, residential property on the other, and you see the cut through there in the center. That is for emergency vehicles. And this is a signalized R-CUT. This would really only work at a signalized version, because if it's unsignalized, well, I'll explain it here in a second. Here's a close-up view. This is in Maryland, and if it was unsignalized, it would open up the opportunity for non-emergency vehicles to try to make that cut through. But when it's signalized, here's why it works so well, if you think about it. So traffic coming up from the minor street, this is another example of a triple right. So 3 lanes coming up from the minor street, making the right turn. The right turn maneuver, they get the green at the same time that the left turns from the major to the minor are being made. So for someone to try to make that cut through illegally, well, not only well, if you violate the red light, you got to cut across the 3 lanes of traffic on the major street, and you're running a red light. If you're trying to do it on the green light, you're going to have the conflict with the left turning vehicles. So it's very much self-enforcing for vehicles to not do the cut through, and the violation rate pretty low. For emergency vehicles with flashing lights, slow moving conditions, hopefully all traffic stopped, it can work a lot better. So it is a possibility. You don't see these at a majority of our cuts, but it is an option if needed. You also see the pedestrian crossing there down the middle and going across that, just a paved area for emergency vehicles only. Another strategy that's probably more common for emergency vehicles is to subtly change the type of curbing. So you see in the very center there, it is a mountable curb. It's a sloped curb. So a police vehicle, even a fire truck could ride over that mountable curbing if needed. That's probably a more typical way of doing it. Most passenger cars probably don't even notice that the curbing has changed, and violation rates, while some people may do it, it's still relatively low. So there are opportunities for advantages to pedestrians and cyclists. I want to talk about some of the other design considerations Intersection skew, well, depending upon which way the skew is oriented, it can be favorable for the left turns from the major to the minor or undesirable. Here's an example of a favorable skew for the left turns from the major to the minor. And you notice in that previous picture, actually, let me back up here. So you see here in the picture how we've got this right turn acceleration lane, and same thing over here, this right turn acceleration lane. So let's talk about that a little bit. Is that a good thing or a bad thing? Well, it depends. There's never a universal answer. There's advantages and disadvantages to the right turn acceleration lane or not having that right turn acceleration lane. If you don't have adequate gaps, if traffic volumes on the major street are fairly high and you don't have a lot of gaps, there can be an advantage to allowing traffic to accelerate and come up to near speeds of the major highway and then just merge in to the rightmost lane. Or if you've got a lot of trucks that come out of the minor street, it might be advantageous for trucks to have that right turn acceleration lane rather than turn into the near lane, probably when they're still accelerating, going slower, and maybe being susceptible to rear end crashes. So there are advantages, but the disadvantages, if you provide the right turn acceleration lane and then a merge area, and then for the vehicles that want to make the U-turn, that are making the left or the crossing maneuver, then they've got to make a lane change, another lane change, get into the U-turn bay, decelerate, come to a stop, and then make the U-turn. Well, that distance can get quite long. So a disadvantage of a right turn acceleration lane is typically the U-turn bay gets pushed further back. So that raises a question, what is that optimal distance between the main intersection and the U-turn bay? Well, the answer is it depends. It's the answer to most things in life. Well, what does it depend on? Well, is it signalized or unsignalized? If it's signalized, the signals create the gaps. The U-turn bay can be closer in. The right turn acceleration lane, we just talked about that. If we have a right turn acceleration lane, chances are I need to push the U-turn bay further away from the main intersection. How many lanes do I have to weave across, or how many lane changes do I have to make? Is it a 4-lane highway or a 6-lane? Or do I have an extra lane that I've got to make a change across? Is it primarily passenger cars or a lot of truck traffic coming out of the minor street? Truck traffic, they need longer distances to accelerate. They need larger gaps. The gaps that are available is really a function of mainline volumes. If I have pretty light volume on the major street, I've got a lot of gaps. If I've got higher volumes, I've got fewer gaps. Fewer gaps might mean the need to push the U-turn bay further away. The operating speeds on the main line, are we talking about a 45-mile-an-hour operating speed or a 70 or even higher? Higher operating speeds mean longer distances that influences my deceleration lengths. Sometimes the topography. I'd like to locate those U-turn bays on tangents where curvature is not limiting my sight distance. So sometimes the horizontal alignment influences where that U-turn bay should be. And then there's practical considerations. Like I'm probably not going to locate the U-turn bay on a bridge, or maybe right-of-way availability to construct the bulb out or the loon. Maybe if I go an extra 200 or 300 feet down the road, I can get into less expensive right-of-way to purchase to build that bulb out. Or where's my next adjacent intersection? Maybe that adjacent intersection is close in and I need to push the U-turn bay out. And I could also have a U-turn bay that serves multiple intersections. There's no law that says you have to have one U-turn bay per intersection. If I've got closely spaced intersections, you could actually have a U-turn bay that serves multiple minor streets. So all of these are key considerations that answer that question, how far away should that U-turn bay be? And another is, are we making a direct turn into the U-turn lane, or am I making a turn into the rightmost lane? Here's another issue that some states have encountered. Some states have actually had to change their vehicle code, their law, where if it's directly in the code that says you must turn right into the nearest receiving lane, well, at an R-CUT, if you want to be able to turn directly into that far lane, some states have actually changed that law to allow that at R-CUTs. So do you have a direct turn into the U-turn lane, or does it have to be the right turn lane? So how far that U-turn bay is, it depends. This is kind of on the long side, about 1,200 feet from the main intersection to the turnaround. You see that a right turn acceleration lane is included in this example. Anytime we have a right turn acceleration lane, generally it's going to push that U-turn bay further out. But about 1,200, 1,400 feet, that's kind of on the higher end. This is on the very low end. It's only about 500 feet from the main intersection to the turnaround. So really somewhere between 500 feet and 1,500 feet is probably going to be your range. 1,000 feet is probably quite typical, but you could bring it in if volumes are relatively light, 500 feet or 1,200, even up to 1,500 feet. So it depends. This is one of those things that I don't encourage agencies to try to cookie cut the design. We talk about the value of uniformity and consistency, and I can see that, but this is also the type of thing that we should engineer. And what is the appropriate distance away from the main intersection? It depends. It really does depend. And if it's a signalized R-CUT, typically that U-turn bay can be closer in. Now, if it's signalized, perhaps the key thing that we have to be concerned about is storage length. How many cars are we queuing up to make the U-turn when the signal turns green for that movement? So storage length may actually become the determining factor when we have a signalized version. But generally speaking, signalized R-CUTs, the U-turn bay can be closer in. So another key design consideration is how we handle truck movements. So you see the U-turn here for a larger vehicle. It's that loon or bulb out that allows for the swept path of the larger truck. You can even have dual turnarounds, dual U-turns for trucks. It's really a function of how wide the median is. Typically, if we have a narrow median, we need a wider bulb out. If we have a wider median, it can allow for a skinnier bulb out. Or the bulb out can also serve as an acceleration lane, or extend the acceleration lane, make it a right turn lane at the downstream intersection. Here's an example of that. So the U-turn basically feeds right into a right turn lane. Now there's some challenges here as well. If you have a truck that's making the U-turn maneuver, and then you've got a slower accelerating truck in the right turn lane, and maybe a passenger car coming up from behind that wants to make the right turn. Does the car go in front of the truck or behind the truck? So there are complications or potential conflicts, but generally speaking, it hasn't been too much of a concern, but it is a factor to consider. So there's never a one size fits all that's going to be advantageous in all scenarios. It really depends upon what we're dealing with in terms of our volumes. So those are some of the fundamental design considerations. And lastly, I'll just close out with, are there any special signs or pavement markings needed? Not really. The key signing is coming out of the minor street and letting drivers on the minor approach know that they can only make a right turn. No matter what direction they want to go, they have to make a right turn. Now, there are some agencies that will do something like that hook arrow to indicate that if you wanted to go the other direction, you do so by going down and making a U-turn, or on the right-hand side of the slide, you see that U-turn arrow to try to indicate that, or another option for the route shields is to indicate the U-turn maneuver. These two sign variations were actually studied. The Federal Highway Administration sponsored a study, and driver understanding of these variations were very positive. So these aren't required, but they are options that can be used. And another example for the U-turn bay in advance, just to let drivers know where the U-turn is, and the route shields to provide that maneuver. These are also possible ways of doing that. And then the only other thing, maybe a little different with signing, is for the U-turn bay at a signalized version where we've got dual U-turn bays. And if we want to keep our trucks in the outside lane to be able to take advantage of the bulb out or the turnaround. And another option with markings or delineation, North Carolina started to use this approach to just add a little more target value to that median channelization, and hopefully discourage the illegal cutting across a maneuver. But other than that, nothing really too unique or different about signing and marking for an R-CUT. So all of this information, or most of the information that we presented here today, comes from the Federal Highway Administration's informational guide on the restricted crossing U-turn intersection. This guide is available for free on our webpage. You can download it as a PDF, and it's got more information for details on the R-CUT intersection. Also, another product from FHWA, it's a new video, kind of hot off the presses here. And Paul, I would like to take this opportunity to try to play this video for folks. So if we could pull up the video pod.
Okay, Mark, go ahead and do that. Remember, just go up to sharing.
I'm sorry. Yes, I
No
forgot.
worries. But just so
It's
you know,
yeah,
we do
let's
have
do it.
about 8 questions in the question pod. So
Okay, so let me. We'll have some time at the end here for Q&A.
no worries.
All right, so
Sharing down arrow.
yeah, thanks, Paula.
Mhm.
So let me try and pull this up. So that's a brand new video that FHWA has. I don't even think it's posted to our YouTube channel site yet, but it soon will be. Soon coming on our site. So with that, just a couple of things that I want to point out from that video. You notice the kind of the drive-through where it timed how long it takes for the driver to make a right turn, go down, make a U-turn, and then come back. And it was, I believe, 42 seconds. And that question of how long is it going to take? What's the how much incurred delay will the side street traffic have? And that is pretty typical, somewhere between maybe 40 seconds, maybe up to a minute if they have to wait for a gap. But we're not talking about minutes. We're talking about usually less than a minute, 40 seconds. Less or 50 seconds. But having that answer to that question is very important when you go out to the public, because you're going to be asked that, and having something like this demonstration video to show that it really isn't that long of a time, but that is a common concern, a common complaint that is often raised at public informational meetings. So having that answer in your back pocket is very, very important. And sometimes that delay or that added delay is more than offset by not having to wait for a gap, or having the cars in front of you having to wait for that gap. And so the total reduction in time plus the added time savings when you're on the main highway usually more than make up for that added delay. So, but those are usually the main concerns that we get from the public. So with that, Paula, I guess we've got a little bit of time left for questions, and I guess we've got some fired up.
Yes, we do. Sorry, I was responding to a question. Okay, if anyone wants to see the video again also, and I'm sending this out to everyone, just go to the handout section, click to download the PDF of today's presentation, and the links to both videos that were referenced are included in that document. All right, so first question, it came in a while ago. We have, when would you choose to implement an R-CUT versus a modern roundabout? That came in from Greg.
Yeah, great question. So modern roundabout, another fantastic intersection choice, especially a single lane roundabout, or even a 2x1 type of roundabout. But when we get into, say, a context of a rural, higher speed, 4-lane divided, and a minor street where the traffic volumes on the minor street are pretty minor, we're probably not going to be looking at a roundabout in that kind of context. The roundabout might come into play if the minor street volumes start to pick up higher, and I would certainly encourage a roundabout when we start thinking about a signal. But it's hard to say when the niche of one ends and the niche of the other begins. So I certainly encourage assessing the full array of intersection choices that we have. But certainly an R-CUT is going to be favorable when we've got really lower minor street volumes, and we wouldn't want to impede the major street traffic for that. But as volumes pick up, and maybe if we're starting to consider signalization, then certainly the roundabout should be in the mix as well. So great question, and that's really why we're seeing agencies really take on opportunities to examine a wider array of intersection choices and look at what is the proper choice for that context and volume combination that they're dealing with. So great question. No definitive answer where the realm of one ends and the other begins, but certainly there's a little bit of overlap there, and also looking ahead to the larger traffic volume demands. But certainly anytime we start getting into multi-lane roundabouts, we do start to have other safety issues that can pop up. So once we start getting above the realm of a 2x1 roundabout, that may be another example of where the R-CUT may start to take over. So great question. Next one, Paul.
Next one comes in from Juan. Is there a median size limit or only on rural, not urban typical section speed? Maybe you understand. I don't know.
If I'm understanding correctly, so we've got a lot of flexibility in terms of the median width, and even with a pretty narrow median, it might still be possible if we construct a larger turnaround or loon area. So we've got options and really not any bounds necessarily in terms of the median width. It's just a trade-off. A narrower median is typically going to mean a wider bulb out loon or turnaround.
Okay. Next question comes in from Richard. Must the left turns from the main line be totally protected or permissive protected?
Great question. So, yeah, I mean, theoretically, so in an unsignalized condition, obviously the left turns are permissive. So if we're going to have a signalized version, could we do something like a flashing yellow arrow, perhaps, so that if there are sufficient gaps, that those left turns could be made. So yes, it is possible. It is a safety or a potential safety trade-off, where yes, we may be reducing the delay to the left turning vehicles, but if the sight lines are clear and adequate traffic volume gaps exist, and well, speeds would be another factor, but yeah, it is possible. It is possible, especially if we implement something like the flashing yellow arrow, making sure we get our signal head locations properly set up. Yeah, so it's something that could be done, but trade-offs would be involved. Good question.
Okay, this comes in from Christopher. Is there any feedback from the sight impairment community on their experience when crossing an R-CUT intersection?
Yes, great question. So far, and I guess it is important to remember the context or what the alternative might be. So if we're dealing with a signalized R-CUT, high volume arterial, yeah, because you've got to compare apples to apples. And anytime we get into big intersections, high volumes, there's a intimidation factor. But there are some advantages with the Z pattern because it's fewer lanes to cross at a time. And from the visually impaired pedestrian, that is a significant factor. And so even with a 6-lane arterial, you might only be crossing 3 lanes at a time, get to the center. And the center channelization, if it includes something like a cutout for the pedestrian pathway, so the visually impaired pedestrian can be realigned, reoriented, and of course, providing full accessibility treatments, truncated domes, accessible pedestrian signals, all of those things can actually make the R-CUT more advantageous. You know, it's still a high volume, potentially complex intersection, but compared to its alternative, which might be a 6-lane arterial with a wide crossing, there are potential advantages. So from a accessibility standpoint, they can be accessible, and it's really hard to say about overall consensus, but there has been feedback from elements of the visually impaired community that actually see the advantages or find the advantages to the signalized R-CUT? Excellent question. Next one.
Okay, next from Richard. On the bicycle cut through, are motorcycles allowed to use that movement too? How do you deter motorcyclists if not permitted?
Great question. Yeah, generally motorcyclists would not be or not be desirable. I'm not aware of anything in terms of signing that would indicate that. But yeah, it would really just be for bicycles, and that type of cut through is still a rarity. Most R-CUTs do not include that, but it really is not intended for motorcyclists. It would just be for bicycles.
Okay. Next question comes in from Jonathan. And he asks, is there any guidance or best practices regarding the minimum distance an R-CUT U-turn intersection should be near a freeway interchange, specifically an upstream off-ramp that is, an upstream off-ramp that is a merge condition?
So yeah, great question. I'm not aware of anything. Yeah, it's a little more complex there, but no, I would still say that it's a situation where we should really try to engineer what that distance should be. Good question.
Okay. The next one comes in from Grant. What is stopping people from making a U-turn in the left-only lane of the intersection?
What is stopping people from making a U-turn in the left-only lane? So I'm guessing the direct or the left turn bay from the major to the minor. Yeah, the geometry might make that awkward to do, but a driver could do it. And if we've got the situation of a raised median, and if there are driveways down there, you might find that scenario happening. So some agencies would put in a no U-turn sign to try to prohibit it, but it could be done. It's just one of those things that usually the geometry doesn't make it inviting to do it. But if volumes are really low, if no one's coming out making the right turn, yeah, it can happen, but usually not too frequently, and hadn't been too problematic. There's nothing physically stopping someone from doing it.
Okay, coming in from Matthew. Have agencies experienced crash problems relating to introducing curb median islands on high-speed rural facilities? What best practices for design are used to minimize the potential of cars hitting these curbs?
Yeah, great question. So usually the sloping curb is utilized, and the sloping curb being more forgiving if it is errantly hit. So that's usually very typical, is a sloping curb that's used for that median channelization area, as opposed to a vertical curb.
Okay, next question comes in from Andrew. Are there any examples that have been built where the U-turn is beyond an adjacent intersection? Would be curious to see how the signing was done.
Yeah, so if the U-turn bay accommodates multiple intersections, it's further down, and we try not to put those U-turn bays too far down to increase the circuity of travel, but it is possible to do that. And it's really, in terms of signing, if it's really far down, could even put in some type of guide that alerts drivers to where that U-turn is, kind of showing the U-turn sign, but with a distance, a plaque perhaps underneath it, if it's really that far down. But if it's visible, that's a huge benefit if the motorist can see the location of the U-turn bay. And if it's 1,000 feet or even 1,200 feet away from the main intersection, typically it is going to be visible unless we're in a curve situation.
Okay, from Adam, are there any special design considerations if there is a railroad crossing on the minor street close to the major street?
Great question. Yeah, so it obviously would have to be a consideration. So like anything, it's how much queuing space do we have for vehicles? If it's a active crossing with gates that come down, or even without, just the queuing that we have for vehicles. We hope that drivers that are either making the right turn from the major or the left turn from the major don't block one of the through lanes, but that is possible, and I guess as a consideration, kind of what we do at it. Normal intersection could be things like blank out signs warning vehicles if it's not a signalized intersection, just to alert them to the fact that there is a train coming. So yeah, I would say it's probably very similar to what we would want to consider at a normal intersection.
Okay, great. Next question is, what has experience been with U-turns on super elevated pavement and or curves? If going a standard distance for the U-turn is put in a super elevated section, would you then push the U-turn further to get out of a super red pavement section? Or are there any locations that have been studied for this type of condition? And that came in from Jerry.
All right, Jerry. So yeah, good question. So if we're in a super elevated section, we're probably on a curve, and so there's issues of sight distance issues. Probably that in a curvature, the sight distance issue probably is the main concern. Adverse super, well, if we're having adverse super coming down to the U-turn bay, well, speeds are gonna be decelerating. So yeah, I generally don't freak out too much with adverse super for slowing conditions for things like coming into the U-turn bay. But if we've got a high rate of super elevation, it's probably the curvature that may be more problematic. So pushing the U-turn bay further away is a potential option. Yep.
Okay, what are the typical costs associated for an R-CUT?
Great question. So obviously it does depend. Signalization is going to raise the cost, but for a very modest R-CUT in a rural area, it's actually even been done by some agencies almost like through a maintenance contract. It depends upon what your abilities are for getting some minor amounts of asphalt out there, and possibly even creating your own signing. So, generally speaking, it could be a very modest project, 100,000, 200,000, all the way up to for signals, and there are additional mast arms at the U-turn locations, obviously, running the conduit wire out to those locations. So yeah, you can certainly get up to the $1 million plus price tag as well. So it does greatly vary, but it's generally a lower cost option for a rural setting. But certainly depends upon how much repaving is being done, and whether any earthwork has to be done to the median, or drainage added to it as well. But generally speaking, they are lower cost options.
Okay. What is the opinion of the general public when it is presented? I'm guessing.
Yeah. So
Okay.
as I mentioned, the typical concern is the circuity, the minor street traffic. And so it's very important to articulate the main message of why this is being proposed. And it's really about safety. And it's those local citizens that are coming out of that minor street. They're family members, they're neighbors that are the ones that are put through the risk of going through a traditional open median intersection. And they're the folks that get the main safety advantages. And in terms of added circuity, added travel time, It's probably going to be in that 40-second, 50-second range. And it's important to articulate that. And in the grand scheme of things, that's a minor investment of time for the benefit of the safer journey to make that crossing through the intersection.
Okay, next question. How much do the R-CUT characteristics differ from those of a CFI?
Yes, very different. So the continuous flow intersection or displaced left turn intersection, another innovative design, but that design basically takes the direct left turns, crosses the left turn lanes over onto the opposite side of oncoming traffic in advance of the intersection. So the CFI, the continuous flow intersection, is a great tool for when you have very high left turn or just a higher left turn demands. But typically that is going to be more of a higher volume suburban type of application. So it's hard to say exactly when one design would fall out of a niche and the other enters into it. But typically the continuous flow intersection probably going to be a higher volume type of scenario. So it is a different innovative intersection. Similar in that the advantage of the CFI is allowing for the left turn movement to occur without the need for an exclusive left turn phase. The protected left turn signal phase at a CFI basically occurs simultaneously or concurrently with the through movement. So it's another way of reducing the number of signal phases compared to a traditional intersection, but certainly distinctly different from the R-CUT.
Okay, next one comes in from Perry. Has speed reduction signage been used on multi-lane main line for the left turn from the R-CUT?
Yeah, I'm not sure. So I'm envisioning that you could have well, I guess an advisory. No, I'm not aware of that example. It would just, I guess, primarily be a case of hopefully having the geometry where it would be an offset type of left turn bait created, and hopefully the geometry would be sufficient to start to slow speeds for the left turning vehicles.
Okay, does the requirement of having a large right-of-way make an R-CUT more like an extreme countermeasure for agencies?
Could you repeat that question, Paul? I'm not sure I understood that.
Sure. Does the requirement of having a large right-of-way make R-CUT more like an extreme countermeasure for agencies? That's how.
Yeah, I'm not sure how to answer that one because I don't know what is meant by extreme right of way. So typically, what we're dealing with a 4-lane divided highway that if it exists or if it's being built, it's being built. The R-CUT is really just a choice of the intersection, and really the R-CUT doesn't expand the footprint over a traditional intersection, maybe with the exception of the bulb out or turnaround for the U-turn bay. So typically the R-CUT is not viewed as being a option that requires extensively more right-of-way than a traditional option.
Okay, we got one more come in. Essentially, the R-CUT operates as a separate one-way main street. Therefore, seems 2 controllers would be best. One controller would control the northbound main line left turn coordinated with the same northbound traffic at the same direction U-turn.
Yes, great point. Great point. So yes, you're correct that when we get into some of the what I'll call more sophisticated opportunities to operate the signals with a corridor of R-CUTs, because you're absolutely right, a corridor of R-CUTs, we can treat them like one-way streets, one-way pairs. And yes, if we're going to do fancy things, changing the cycle lengths based upon direction, you're absolutely right. Having multiple controllers per direction opens up a lot of advantages in that regard. That is true. For a isolated R-CUT, if we're going to keep things simple, a single controller could be done, but you're absolutely right. If we're going to get into the fancy stuff along a corridor of R-CUTs, yes, there are advantages to doing that with controllers per direction. Good point. Very good point.
All right, Mark, that was the last question.
All right, Paula. So I just want to thank everyone again. Those were great questions. Obviously, a lot of thought and great interest in R-CUTs. On that second slide, I've given you my contact information, my email address, my phone number. And by all means, if you have further questions or ideas, by all means, feel free to reach out and drop me a line. Be happy to chat with you further.
And we are recording this presentation today, so we will be able to provide this information again to you all at a different date. Check out our LTAP newsletter to receive additional information on that. All right, thank you, Mark.
Thank you, Paula, and thank you everyone for participating.